In my last video, I discussed about trees. We have seen what exactly are trees and what are the theorems related to trees. Now, right now in this video, I will talk about rooted trees. Right? So, what exactly is a rooted tree? So, first of all, it is a directed tree. Now, if you remember in the very first video, I told you what is a directed graph? A graph with the directions. Right? For example, if this is a graph, if I mention the direction at each edge, then it is called the directed graph. So we will be talking about a directed tree. Okay. So a directed tree is called rooted tree. Okay. Is called rooted tree if it satisfied two conditions. First condition, T contains a unique vertex. Okay. T contains a unique vertex called root with in degree 0. Right? Second, in degree of all other vertex is 1. Now understand this concept first. When you remember the definitions in points, it is easy to memorize them without skipping the main important terms. Now, the very first thing when I am defining a directed tree. So all of you must remember what exactly is a tree. Okay. So now suppose I am making this tree. Right. Now this is a tree. What I am saying, a directed tree means every edge has a direction and a downward direction. Okay. So every edge has a downward direction. That is a main important thing. Then what I am saying, what is the first condition? T contains a unique vertex. Okay. T contains a unique vertex called root with in degree 0. So what is this word in degree means? If you remember in the directed graph, I told you if this is a vertex, whatever is going inside is called in degree. Like in degree of this vertex is 1 and out degree of this vertex is also 1. Right? Suppose I have one more edge like this. So for this I can say the 2 degree is, out degree is 1, 2, 3. And what is the in degree? 0. Right? So whatever is coming inside is in degree. Whatever is going out from that vertex is called out degree. So I need a special vertex called root with in degree 0. Like here when I have drawn the tree, this vertex, if you observe, this is root. Because I am starting from here and nothing is going inside it. Okay. So there was one more word I used earlier, source, from where everything is coming out. So basically I should have a source. Or best easy thing, the T contains a unique vertex called root with in degree 0. And in degree of all other vertex should be 1. Means every vertex should have in degree 1. Like this is 1, this is 1, this is 1. So every vertex has a in degree 1. Only one vertex should have a in degree as 0 and that is known as root. Correct? Now, there are few vertex with out degree 0. What are those vertex? Can you figure out here? This one, this one, this one and this one. So these are the vertex with out degree is equal to 0. And they are known as leaves. And I will be representing them by P. Correct? So, apart from leaf, whatever vertex are available, like this, including root. They are known as internal vertex. And they are represented by Q. Overall, all the vertex are represented by N, that we already know, right? So all the vertex are represented by N, internal vertex by Q, and leaves by P, and there is one special root. Correct? Now, apart from this, what else I need to discuss here is the level. What is the level of rooted tree? See, the root is always at the 0th level. Okay? The root is at the 0th level. If you observe this one and this one vertex, they are first level. Okay? Then this one, this one, this one and this one, they are at the second level. Okay? Then this one and this one are at the third level. So like this, based on your root and your distance from the root, I define the level. Basically, to go from one vertex to other vertex, there will be only one path. And the length of the path is called the level. So how I define a level? Level is the length of path from root. Okay? And it is represented by H. When I talk about the rooted tree, it is represented by H. Okay? So this is one thing you need to understand. So kth level means if there is a vertex with the kth level, I can say that the length of the path from this to the... So when I say that a vertex has the kth level, means the length of the path from root to that vertex is k. So that is the one concept. Correct? Now since we are very clear about the basic terms, let us go to one more level. Okay, so now look at this diagram, this graph. Now here this R is the root. Then V1 and V7 are at the level 1. Okay, so V1 and V7 are at first level. So I can say that H is equal to 1 for them. Same way, I can say that for V2, V3, V8, V9, I am saying H is equal to 2. Because if I am talking about V9, look at this. 1, 2, path length. V8, 1, 2. V3, 1, 2. V4, V2, 1, 2. So I can say that for V2, V8, V9 and V3, H is equal to 2. Right? Same way for V10, V6, V4 and V5, H is equal to 3. So these are the levels. Now here there is one more interesting thing which you can easily connect with the family trees. Now here, since from V1 I am having V2 and V3. So V1 is called the parent of V2 and V3, and V2 and V3 are called the siblings. Right? And V1 is also known as, and all the vertex above something like for V4, V5, V6, V1 are the ancestors. Right? Same way for V3, V4 and V5 are the child and V3 is a parent, and V4 and V5 is treated as a siblings. For V2, one child, V6 is there. So this is also defined in when we talk about the rooted trees. Right? Here what are the leaves? V6, V4, V5, V8 and V10 are the leaves. And remaining all are the internal vertex, interior vertex. Okay. Now here we will understand one more extra thing, which is known as M-array tree. Now what is M-array tree? If out degree of every internal vertex is less than out degree of internal vertex. Okay. is less than or equal to m, then it is known as M-array tree. And if this is m value is 2, then it is called the binary tree. Correct? Now one more thing I can put here. If suppose the out degree is exactly m, then it is called the complete M array. Okay, see, when it is less than or equal to m means it can be m or it can be less than m, like that, but maximum will be m. But different vertex will have the different degrees, right? So that time I will call it M array tree. But if it is same for all, okay, it is exactly m, then it is known as complete M array tree. Now in this case, if m is equal to 2, it is called complete binary tree. Okay, it is called complete binary tree. Right? Now here, one more concept we will understand, ki what is a balanced tree and what is a unbalanced tree. See, now here I have defined the level of each vertex. Okay, suppose the highest level, let me write balanced tree. Now suppose the highest level is H. Okay, and if the level of all the vertex is H or H minus 1, then it is called balanced tree. Like here in this example, if you observe, I do have the vertex with level 1 also, 2 also, and 3 is the highest level. So it is not a balanced tree. Okay, it is not a balanced tree. For being a balanced tree, the level has to be either H or H minus 1. Correct? Let me give you a simple example for this. And when I say like this binary tree, if every vertex t is of degree less than or equal to 2, that way also I can say like every vertex has 2 children. Like in terms of child, if I want to talk, every vertex has 2 children. Right? Anyways, that I'll explain you. Now here I have told you what exactly is a balanced tree. Now suppose if a binary tree is balanced, okay, or in other words, like that we should say, suppose if there is a tree T and it is a complete binary tree, okay, with all leaves at level H, then it is called full binary tree. Then it is called full binary tree. Correct? I'll give you some examples so that it will be more clear to you. Suppose I have one tree like this R. I'm not making the directions. Understand that it is a rooted tree, so it will have a direction. It will be a rooted, directed one. Okay. So now this and this. Okay. Now here 1, 2, 3 and like this and this. Now tell me one thing. Is it a binary tree? So what you have to check for binary tree, you need to check the out degree of every vertex. What is the out degree of this vertex? 2. What is the out degree of this vertex? 2. What is the out degree of this vertex? This vertex, it is 1. Right? Now another one. Go this side. What is the out degree of this? 1. What is the out degree of this? 1. What is the out degree of this? 2. So apart from leaf, when I saw all the vertex, means all the internal vertex, the out degree is either 2 or it is less than 2. So it is a binary tree. Correct? It is a binary tree. I am not saying that it is a complete binary tree. It is a binary tree. right? It is not complete binary tree. Why it is not complete? Because few vertex have the out degree 1. If all vertex have the out degree 2, then it will be complete binary tree. Correct. Now let me talk about the balanced. Is it a balanced one? Let me check. 1, 2, 3, 4. So highest level I can see is 4. Let me check here also. 1, 2. 1, 2, 3. Highest level is 4. But I can see the vertex at level 1 also, 2 also, 3 also. So it is not the balanced one. Correct. If you see the height of the vertex, let me check again so that we should not do a mistake. Now if I check the height of these two, so 1, 2, 3 and 4. Correct. Now check the height of this vertex. 1, 2, 3. Okay, this is another leaf 4, 4, and this is another leaf 1 and 2. So this is 2. So my leaves are at the level 2, 3, 4. So it is not balanced one. Now suppose if I extend it like this. So my this leaf will come at the order 3. Because we have to check the level of leaf only. So now see, all the leaves are at the level 3 or 4. So then it will become balanced. So it is balanced in this case. Understood? This for balance only I have done this extension. Okay. So now you understood what is a binary tree, not complete binary tree, and what is a balanced tree. Right. Now let me give you one example of complete binary tree. Now complete binary tree means if this is root, these are two vertex. Okay. Now from this vertex I can take one more here. Now one more here and one more here. Same way here also I can do one more here, one more here, one more here, one more here, one more here and one more here. Now what is the degree of this, out degree of this one? 2, because 2 are coming out. What is the out degree of this? 2. What is the out degree of this one? So I should make it like this. So out degree of this one is again 2. Out degree of this one is also 2. 2. Out degree of this is also 2. So it is complete binary tree. Now whether it is balanced or not, for balanced or not, what you will check? You will check the level of leaf. So 1, 2, 3. This is at the third level. 1, 2, 3. Third level. 1, 2, 3, 4. Fourth level. This is also fourth level. Now 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. So just because of this vertex, it is not a balanced tree. So it is not a full binary. If in case I extend this also here, it will become 3 and then it will become full binary. Understood? So this is a simple concept. Now if I want to make a full binary, let me give you one example of full binary also. If this is a root, right? So make like this, exactly symmetric if it comes, then it is full binary, like this. See, that is the perfect one. So this is full binary. Because all leaves are at the level of H. This is not full binary even if I extend this. Because for full binary, all leaves should be at the same level of H. Correct? So this is full binary. Right? So these were the basic terms. Now let us learn a concept to do the numericals based on this. Now suppose if T is a complete M-array tree with order n, means total number of vertex are n. Remember when I say total number of vertex, it will be always represented by n, which will include root also. P is leaves and Q are the internal vertex, and internal vertex also include root also. Because how I define internal vertex, the vertex apart from the leaves are called the internal vertex, right? So there is a relation between all this. The derivation of relation is not required. You just remember the relation for the numericals, like n is equal to, when you can prove this easily, it's not difficult, it's easy only. So these are the 3-4 relations which we will be using. Now let us see how to apply them on the questions, right? Now let us see the first question. Now look at the first question. What they are saying: find the number of vertices. Number of vertices means n, I don't know. Okay. Then the number of leaves. Okay. So P also I don't know. Okay. In a complete binary tree, if I am saying complete binary tree means m is equal to 2. Because binary means m value will be 2. If I say 5 array means m will become 5. If I say 6 array then m will become 6. Like that. The moment I use the word binary means m value is given as 2. Okay. So now let us start with that. So having 10 internal vertices means q is equal to 10. Correct? Q is equal to 10. Now how to solve this question? So go back to the relation. Since I want n and p, you should search a relation with n and p. So if you look at this one, you have m, you have q. So you can use this relation. Let me use this. So p is equal to m minus 1 q plus 1. So p I don't know. M is 2. So 2 minus 1 into 10 plus 1. So it is 11. Correct? And the second thing I need n. Now what is the relation for n? N is equal to, look at this, n is equal to 2q plus 1. N is equal to mq plus 1, right? So when I have n is equal to mq plus 1, what is m here? 2. What is q here? 10 plus 1. So 21. Answer. So only read and understand the terms, remember the formula and then you can do the question. Look at this one. How many internal vertices does a complete 5 array tree with 817 leaves have? Now 817 leaves means P is equal to 817. M array means M is equal to 5. Internal vertices means Q is something unknown which you have to find out. Right? So now what is the relation? Go back to the relation, search the relation. Look at this one. So easily it is giving. Right? So now I have Q is equal to this one because N I don't have. So this one is useful. Q is equal to P minus 1 upon N minus 1. So Q is equal to P minus 1 upon M minus 1. So P minus 1 will be 816. M minus 1 will be 4, which is equal to 204, which is my answer. Same way, let us see one more. Now M is equal to 6 and P is equal to 733. Oh, sorry, N is equal to 733. Order, right? N is equal to order. And you have to find out P. So what is the relation now? Now see, direct P, M, N I don't have. So I'll go for Q. Q is N minus 1 upon M, which is 732 upon 6. Correct? So what is the P? P is equal to 5, 732 upon 6 plus 1. We have done MQ plus 1. So I have applied that formula, which will give me 611 as the answer. Easy? So questions are easy, only you need to remember the formula. Now this question is very important for exam point of view. See, I will explain you with the formula also and I will explain you with the concept also. Now the computer lab of a school has 10 computers. Okay, that are to be connected to a wall socket that has 2 outlets. So suppose this is a wall socket and it has 2 outlets. Okay. Now connections are made by using extension cords that have 2 outlets each. So now this, suppose this is an outlet, right? So I can fix one socket here. So if I fix one socket here, what will happen? The socket has 2 outputs. So at one output I can put a computer and the other output I have to put another socket. Right? So now here again I can put one computer. Then again I can put one socket and here I can fix one computer. Right? So this is V1, V2 V3. Now one more I'll put V4. So here I can put a computer C5. Here I can put the computer C6. Now let me do the other side also. Now here if I put one socket, so one socket will be like this. Okay, and one computer I can fix. So I will reach to 7th computer. Here one socket I will fix. Then one computer I will fix. So this is now we reach to V4. So V5. Okay. And V5 here also I can put na. This is a socket, so it will have one. So one put here and here. C7, C8, suppose C9. So I don't need any more socket. C10. Now you count how many cords you have attached. First it was the socket, right, which has two outlets. Now from here you have attached the extension. So how many? V5, V6, V7, right? Okay, now see here, where is your fourth computer? I have not put the fourth computer only, I have put fifth directly. So I'll put here C4 and this is C5. So this will be your C6, C7, C8 and then C9 and here C10. So this will be V8. So how many extension I required? 8 extension I have required. Right. So this, so graphically I have tried to understand the problem. Now let me do it by using the formula. Now if I use the formula, how many computers you have? Computers means it will be the leaves. So P is equal to 10. Correct. And the number of internal vertices of the tree will be how many? That is Q is equal to 10 minus 1 because it is binary. Right. So M will be equal to 2. So if you put M is equal to 2 in the formula, you will get Q is equal to 9. And Q is equal to 9 means total internal vertex are 9. But I know that internal vertex also include the root. Correct? So how many extensions are there? So total extensions are 8 only. So that is my answer. And that is what I have done with the diagram also. So this question is very important for exam point of view. Now this type of one more question is there. The only difference is there that there are 25 computers in that. Okay, computers, number of computers are 25 and also the sockets are there. 4 sockets are there. In every extension there are 4 sockets. Okay, so if the number of computers are 25 and if the wall socket and the extension cords have 4 outlets, find the least number of cords needed. So if I go by the formula, see obviously you can't draw with 25 computers. So my P is equal to 25. Okay. And M is equal to 4. Now it is not 2. Now M is equal to 4. Correct. So what is my formula? Now you go back and you check. What is your formula? Now see here. Which formula I am applying? I can apply, see, I have P, I have M. And what exactly I am searching? I am searching the number of extensions, right? So see what is given, P is 25, M is 4 and Q is unknown. So apply this formula and you will get Q is equal to 8. But we know that Q involves the root also. So the number of extension will be 7. So both the questions are very, very important. So we are done with the basic of rooted tree. Now in my next video, I will be putting spanning tree and how to get the minimal spanning tree normally and how to get the minimal spanning tree using Kruskal's algorithm. And after that one more video, I will tell you the cut set and the flow problems. Subscribe the channel so that immediately you will come to know that I have updated the video. Thank you.